So an important factor to keep in mind when you're setting up your hardware teams is the tools you choose need to have sufficient transparency. What does that mean? Software tools, CAD, PLM, PDM, ERP, for a long time have been very powerful, but very opaque. They're separate standalone applications that have their own individual user access, their own installations. And as a result, it was very difficult for other team members to see what was going on, what an individual was generating in CAD, or how they were managing the data in PLM, because of the opaqueness and the friction to access that information. It was very expensive to add user licenses just to be able to read and access the information. And as a result, the information was often held much longer than it should be, adding inefficiencies to the time frame, cost, and elongating how long it took to get to production. So when you're picking your tools, make sure that the software itself makes it easier to disseminate the information, get information in and out. Often that means starting with cloud-native products, simpler user licensing models, and easier processes themselves to get data in and out. Because when you have greater transparency about what each team is doing, you get to a better place where you have more people that can contribute their own specialized skills and provide feedback and awareness so that the overall throughput and efficiency going from design to production is much higher. When you serialize the steps and people are, the proverbial throwing it over the wall and receiving the information and seeing it firsthand well after it's been produced, the opportunity for feedback or improvements is lost, or the time to provide that feedback and improvements is lost. And so tools today are becoming much, much more transparent, but it's important to continue to pushing on the industry to promote that transparency and simplicity for data migration and dissemination. So a very concrete example of a lack of data transparency is CAD tools. So mechanical CAD, electrical CAD, traditionally are Windows desktop applications, not cloud native, expensive user licensing models, and they're binary files, often of proprietary formats. And so it's difficult for a mechanical CAD engineer or electrical CAD engineer to share what they're working on midway through the design process. The number of steps it takes to publish their information is high. The cost to do it is high. The friction level is high. And so as a result, they're reluctant to do it more often. They wait to a major milestone till they're finished with the revision or they're ready for review. And as a result, you lose all the opportunity for feedback sooner in that workflow process. And so the simpler it is for CAD engineers to share what they're working on with other team members, other CAD engineers, managers, procurement officers, technicians, who can all look at those designs and provide their own feedback from their respective perspective, the greater the design is going to be and more efficiently get there.